Welcome back to my channel Math School. In today's video, let us solve the question number 3, part 1, 2 and 3 from exercise 3.2, chapter 3, pair of linear equations in two variables. In my previous videos, I have completed the questions 1 and 2, examples 1 to 6 and exercise 3.1. If you have not watched these videos, do find the link in the description box below or click the I button above. So now quickly, let us begin with the video. Question number 3 from exercise 3.2, chapter 3, pair of linear equations in two variables says, on comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the following pair of linear equations are consistent or inconsistent. So there are 5 parts of the questions given, and in each part they have given a pair of linear equations. So here we have to find out whether the following pair of equations are consistent or inconsistent. What is the meaning of consistent or inconsistent? Consistent means the pair of linear equation which gives us a solution. It can be a unique solution or it can be a number of solutions. For example, the intersecting lines and the coincident lines gives us a solution, whereas the parallel lines are inconsistent because there is no solution when we graphically plot a pair of linear equations which are parallel, right? So this I have already explained in my previous videos and also the introduction part of exercise 3.2. So do watch those videos before solving these problems. So general form of a pair of linear equations is given by a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. This is the general equation for a pair of linear equation. Now, using the ratios a1 by a2, b1 by b2 and c1 by c2, we will find out whether the given pair of linear equations are consistent or inconsistent, right? The first category is when the lines are intersecting, then the ratios will be a1 by a2 will not be equal to b1 by b2. So at this point we obtain a unique solution, and also since we obtain a solution, the pair of linear equations will be consistent. Second condition is when the lines are parallel, then the relationship between the ratios will be a1 by a2 will be equal to b1 by b2, but that will not be equal to c1 by c2. Hence we obtain no solution since the lines will be parallel to each other, and since we obtain no solution, we can say that the pair of linear equations are inconsistent. Okay, so the third condition is when the lines are coincident or overlapping. In this situation, the relationship between the ratios will be a1 by a2 will be equal to b1 by b2, and that will be equal to c1 by c2. Here, since the lines are coincident or overlapping, we obtain infinite number of solutions, and since we obtain solution here, the pair of linear equations will be consistent, right? So this is the table which is very much important. You have to know to solve these kinds of problems. So now let us solve the first part of the question and find out whether the lines are consistent or inconsistent. When you compare these equations to the general form of pair of linear equation, these general form of pair of linear equations have been equated to 0. So first of all, let us equate the given equation to 0. From the first equation, sending this 5 to left hand side, we get 3x plus 2y minus 5. This plus 5 is going to become minus 5 equal to 0. Similarly, the second equation, 2x minus 3y, this plus 7 will become minus 7 equal to 0. So now, comparing with the general form of equation, let us write the coefficient of x, y and the constant c. So from the first equation, the coefficient of x is equal to 3. Coefficient of y, b1 is equal to 2, and the constant c1 will be minus 5. Similarly, from the second equation, coefficient of x, a2 is equal to 2, coefficient of y, b2 is equal to minus 3, and the constant c2 will be equal to minus 7. Now let us write down the ratios a1 by a2, b1 by b2 and c1 by c2. a1 by a2 is equal to 3 by 2. Similarly, b1 by b2 will be equal to, since we have minus, we are writing minus, b1 is 2 and b2 is 3. So it is minus 2 by 3, and C1 by C2 will be minus 5 divided by minus 7. Since minus and minus will get cancelled and will get plus 5 by 7. So now if you consider conditions given here for intersecting parallel and coincident line, we can notice that A1 by A2 is not equal to B1 by B2. If this condition occurs, we can say that the lines are intersecting lines. Hence, we will have one unique solution, and therefore, since we obtain a solution, the lines will be consistent. For the other two conditions, A1 by A2 is equal to B1 by B2. So these two conditions are not possible, that is parallel and the coincident lines. So therefore, we can write, since A1 by A2 is equal to B1 by B2, so therefore we have intersecting lines, and hence therefore we can say that the given pair of linear equations are consistent. So similarly, let us solve the second part of the question. The second part of the problem from the question number 3, the equations are given here. So let us equate these equations to 0 before finding out the coefficients A1, A2, B1, B2 and C1, C2. First equation can be written as 2x minus 3y minus 8 equal to 0. Similarly, 4x minus 6y, this plus 9 when sent to the left hand side, we get minus 9 equal to 0. Now comparing this with the general form of pair of linear equation and finding out the coefficients, A1 is equal to 2 from the first equation, B1 is equal to minus 3 and C1 is equal to minus 8, right? Similarly, A2 is equal to 4, B2 is equal to minus 6 and C2 is equal to minus 9. Now write down the ratios A1 by A2. A1 by A2 will be 2 by 4, cancelling 2 1 times, 2 2 times, so we get 1 by 2. Similarly, what is B1 by B2? B1 by B2 is minus 3 by minus 6. This minus and minus will get cancelled. Again 3 1 times, 3 2 times. So B1 by B2 is 1 by 2. Now C1 by C2 is equal to minus 8 by minus 9. So this minus and minus will get cancelled and you will be left 8 by 9. So here if you compare, the ratio A1 by A2 is 1 by 2 and B1 by B2 is 1 by 2. Therefore, we have A1 by A2 is equal to B1 by B2, right? Now you compare with C1 by C2, it is 8 by 9, which is not equal to the ratios of A1 by A2 and B1 by B2. So when do we obtain such condition? So if you look at here in the table, A1 by A2 is equal to B1 by B2 and not equal to C1 by C2 when the lines are parallel to each other, and when the lines are parallel to each other, we obtain no solution and therefore the lines will be inconsistent. So here, since A1 by A2 is equal to B1 by B2 and it is not equal to the ratio C1 by C2, therefore we obtain parallel lines. Hence we can say that pair of linear equations are inconsistent. Third part of the question number 3, let us first equate them to 0 as the general pair of linear equations equated to 0. Let us write the first equation as 3 by 2x plus 5 by 3y. Let us send this 7 to left hand side. So this will become minus 7 and equal to 0. Similarly, the second equation we can write it as 9x minus 10y. Sending this 14 to left hand side, it will become minus 14 equal to 0. Now let us find out the coefficients A1, B1, C1 and A2, B2, C2, comparing with the general form of the linear pair of equations. From the first equation, the coefficient of x is A1 equal to 3 by 2. Similarly, B1 coefficient of y is 5 by 3 and the constant C1 is minus 7. Similarly, from the second equation, A2 is 9, B2 is minus 10 and C2 is equal to minus 14. Now let us write down the ratios. A1 by A2 is 3 by 2 divided by A2 is 9. And this will be 9 divided by 1. So we will reciprocate this denominator. So 3 by 2 into 1 by 9 we get. Okay, so 3 1 times, 3 3s are 9. So we get here 1 into 1 is 1 divided by 3 into 2 is 6. Similarly, let us find out the ratios B1 by B2. Here B1 is 5 by 3 and B2 is minus 10. So again we get 10 by 1. Reciprocating the denominator, we get 5 by 3 into minus 1 by 10. So cancelling 5 1 times, 5 2 times. So we get this minus will come here. 1 into 1 is 1 divided by 3 2s are 6. So B1 by B2 value is minus 1 by 6. Similarly, let us find out C1 by C2. So C1 by C2 is minus 7 divided by minus 14. So this minus and minus will become plus. So 7 1 times, 7 2 times, which is equal to 1 by 2. So here when you compare the ratios A1 by A2 with B1 by B2, we can see that A1 by A2 is 1 by 6 and B1 by B2 is minus 1 by 6, which are not equal to each other. So when A1 by A2 is not equal to B1 by B2, which is a condition we get, that is the lines will be intersecting, right? We get intersecting lines. So since when the lines are intersecting, we can say that pair of linear equations are consistent since they will get a unique solution, right? So write down, hence the pair of linear equations are consistent. In my next video, I'll be solving part 4 and 5 from question number 3, exercise 3.2, chapter 3, pair of linear equations in two variables. So till then, do like my video, subscribe to my channel, and don't forget to hit the bell button below to get the latest updates of my videos, as I'll be completing the whole syllabus for class 10th SLC NCERT math. And also do watch the related videos of chapter 3, pair of linear equations shown on the screen. Thank you.